and welcome back to another episode of Day Zero to Breakthrough. It's day 38 and Keith, Nick and Jake have decided which vaccine candidates will be lead compounds, going on for further testing and preclinical trials. They've done incredibly well to make a decision very quickly in the face of a daunting challenge. If they've picked wrong, going back and choosing another lead compound will mean lost time, which puts them at risk of missing their 100 days goal. Out of the 26 compounds originally produced as vaccine candidates, only 2 have been chosen as lead compounds. The team carefully considered how each construct performed in the size exclusion chromatography, ensuring maximum trimeric antigen was present with little misfolded protein. They also paid particular attention to the amount of protein each construct produced. This is an important consideration for a real pandemic. The more vaccines we can produce more rapidly, the better we'll be able to protect our community. The candidate called Q had the best combination of high yield, good trimeric protein, and general protein quality, with Z a close second. So, Q is officially our lead compound, with Z as a backup. These letters don't necessarily mean anything, but Q and Z have slight modifications to their sequence compared to the wild-type viral fusion protein that lock them in the pre-fusion conformation. Work with Q was already beginning in the lab. I joined Elsje as she began the process of receptor conformation. What does this mean? Eljse explained that when a virus emerges and threatens a pandemic, it's generally relatively unknown. It's important to understand certain aspects of how a virus functions in order to test the effectiveness of their vaccine moving forwards. Chappare mammarenavirus has not been widely studied, but it's believed it binds to the transferrin receptor to enter and infect our cells. The transferrin receptor is found on cells all throughout your body and normally functions to help you take up iron, which is really important for a range of daily tasks, including carrying oxygen through your blood. Eljse has incubated vaccine candidate Q with pure transferrin receptor. Now, she and Michaela are running the mix through the ACTA machine, using size exclusion chromatography to test whether Q binds to the transferrin receptor. If the transferrin receptor does bind Chappare mammarenavirus, then it should also bind Q. This has the added benefit of making sure Q and Z accurately reflect the shape of the Chappare mammarenavirus fusion protein in the real world. This is just the first of several tests involved in the receptor conformation process, so we'll be following her progress over the next few weeks. Now that the team has selected their lead candidates, they're going to be even busier. So far, we've followed along as they've done one thing at a time, but now they're going to try and juggle several things in parallel to make their rapid response, well, more rapid. Buckle up, folks, we're well on our way from day zero to breakthrough.